Okay, your last section of homework for your summer homework is Unit Circle Section 2. And for the most part, it's going to be just examples of problems to do. The first thing I wanted to cover is something called reference angles, which we've already talked about, so we don't need to spend a lot of time with that. And then using reference angles, we'll answer a few questions like which quadrant would theta be in if, say, the cosine is negative and the tangent is positive, or any variation of different trig functions. We'll find some more problems where they ask you to find the exact value of a trig function given another trig function in a specific quadrant. And then we'll find the exact value, kind of like we did for section 1, only you're going to see that these numbers are much bigger than 2 pi, and all that means is that that's gone around the circle a bunch of times, and so it just makes it a little bit harder to figure out which quadrant it's in. And then we'll finish off by finding the values of theta somewhere between negative 2 pi and pi, so like they'll tell us that the sine of theta is negative 1/2, and we got to figure out what angle makes that true. Alright, so reference angles, like I said, I'm not going to spend a lot of time on that since we looked at that in the last section. That's the idea of paying attention to the denominator if it's in radians, which is typically what we work with, but noticing that all of these things are something pi over 6, which is a 30-degree reference angle, which means 150 is a 30-degree reference angle because it's 30 degrees away from 180, just like 210 is 30 degrees away, or 330 is 30 degrees away from 360, and noticing that those are all something pi over 6s. So it's why the reference angle thing is such a big idea, how if you can notice the denominator is a 6, a 3, a 4, it pretty much tells you the reference angle that you're dealing with, makes it much faster to solve. Alright, so first kind of problem, it's going to ask you which quadrant would theta be in if the cosine of theta is negative or less than 0, and the tangent of theta is positive or greater than 0. So if you think about it, cosine being negative, remember cosine's like an x value, that would mean that you have a negative x value. So if you think about where that is, that means you're going to the left, so you're either in the second or third quadrant, and then it says the tangent is greater than 0. Now I know tangent is y divided by x, and if I'm going to get a positive number, and I already know that x is negative, then that means y has to be negative, so that they will cancel out to get a positive number. So if I have a negative x, negative y, negative x, negative y, I know I'm down here in the third quadrant. So my answer would be third quadrant. So anytime they give you cosine, or secant for that matter, that's telling you something about the x value. If they give you sine or cosecant, that's telling you something about the y value. And if they give you tangent or cotangent, that means when you divide the two, you get a positive or negative number, which means either they're both positive, both negative, or one of each. So you have a few problems that are like that. For the second set of problems, we're going to find the exact values of the following. I guess I only have one, so we'll just do this one. But it's going to ask us to find the cosecant of theta if the secant of theta is negative 7/4. Let's ignore this for right now. So remember what I said in the last section, how I typically work with sine, cosine, and tangent. I usually won't work with one of the other 3 trig functions, and if I have it, I immediately change it. So what I'm going to do is take the reciprocal of both sides. Realistically, I can change this to cosine of theta is equal to, if I take the reciprocal on this side, I have to take the reciprocal on this side also. So I'm going to say that cosine of theta is equal to negative 4/7. So essentially what you're doing over here is this. Secant is really equal to 1 over the cosine. Again, this is you'll see more of this trig stuff next year. But secant is equal to 1 over cosine. So you're saying that 1 over cosine is equal to negative 7/4. Imagine this is just an x and you cross multiplied. You would have 4 is equal to negative 7x, or again, it's really cosine. And then you divide by negative 7. And now the cosine is equal to negative 4/7. So that's what we're doing. You're basically taking the fraction and flipping both sides. Alright, now the cosine being negative, think on the unit circle what that means. If cosine is negative, that means you go to the left. That means you could be here or here. It could be either one of those two. So this is supposed to restrict it. Now they're telling us to go from pi over 2, which is here, all the way over to 3 pi over 2, which is here. So they're basically saying you're going to have 2 answers. Now, let's say I change this, and let's say instead of pi over 2 to 3 pi over 2, I went from 0 to pi. Now I'm going to change my answer back to this, but just for another example. If I'd want the answer to be somewhere between 0 and pi, that means my answer would be somewhere here, which means it would have to be this one. It couldn't be that one because that's not between 0 and pi. Now, that's not originally our problem, so we're not going to do that one. But that's kind of the idea behind it. It usually restricts it. This one didn't, however. This one, they want me to look at these two quadrants, and I happen to have two answers. So I'm going to draw a triangle. Remember, like we said in the last section, you go from wherever this ray is, go to the x-axis, to the origin, and there's your triangle. So I'm just going to draw that over here. And then label, I know cosine is equal to adjacent over hypotenuse, so -4 over hypotenuse. And I know this is the negative because it moved to the left. Now I probably should do another triangle for this. And if you do, you're going to realize that you have exactly the same information. It's -4 and then 7. And for both of these things, you're looking at the angle that's right by the origin. If you had actually drawn this out on an x and y coordinate system, you're looking for the side opposite. So regardless of which triangle you draw, you have to do Pythagorean theorem. So you're going to do a squared, or you can call it b squared if you want, plus b squared. So a squared plus -4 squared equals 7 squared. Or a squared is not equal to, a squared plus 16 is equal to 49. Go ahead and subtract 16, and you end up with 33. And then, of course, I take the square root of both sides, and I'm supposed to have plus or minus the square root of 33. Now, in terms of simplifying the square root of 33, it breaks down into 3 and 11. Those are both prime. I don't have a group of 2, so it stays square root of 33. Now, here's where the plus or minus kicks in. If I was just looking at this triangle, say I was looking at this blue scenario, then it would be positive square root of 33. But since I'm looking at actually both of them, I'm going to have two different answers. I'm going to have one answer for this triangle and one answer for this one. This one is negative square root of 33 because you moved down. Once the triangle is filled out, now you can answer the question. So looking at this triangle, if I want the cosecant, remember you're going to think in terms of sine. Figure out what the sine is and then flip it over. The sine would be opposite over hypotenuse, flip it over. So it's not the square root of 33 over 7. It's going to be 7 over the square root of 33. Same exact answer here. It's going to be negative square root of 33 over 7. Flip it over. It's basically just plus or minus this answer. Make sure you rationalize because you have a square root in the denominator. So rationalize, and I get 7 square roots of 33 over 33. 7 and 33 won't simplify. So my answer, I happen to have two of them. It's plus or minus 7 square roots of 33 over 33. So this is going to help you narrow it down to two quadrants when they give you this. This usually will narrow it down to one. It's very unlikely that you get two answers, but we did for this one. All right, moving on to these. It's the same concept if I asked you to find the cosine of pi over 6. We would say, oh, wait a minute, it's pi over 6. I know it's here. I know the reference angle is 30 degrees, so I know it's the square root of 3 over 2 and 1/2. And I know it's asking for the x value, so it's the square root of 3 over 2. It's the same concept. The difference is it's gone around the circle more than once. And I know that because if I take and look at that number, it's bigger than 2 pi. Remember we said on section 1 that when you count your way around the unit circle, here I'll pull this back over here again from section 1, as I count my way around the circle going this way in a positive direction, once I get to 12 pi over 6, I can say it's 13 pi over 6, 14 pi over 6, 15 pi over 6, 16 pi over 6, 17 pi over 6, 18 pi over 6, and I can keep going forever and ever. Obviously, I need to get to 34. Now, the last thing I want to do is sit there and count 1/6, 1/6, 1/6 until I get to 34. I could. It's just a bad strategy. It'll take you too long. So what we're going to do instead is this. Remember when we were doing those problems, we said don't just look at the denominator immediately. What you should do is see if that fraction will simplify. So I happen to recognize that that fraction will simplify. Those are both even. So I'm going to change this, or simplify this, to the cosine of 17 pi over 3. So that's why you got to be careful, because what looks like it's a 30-degree reference angle really isn't. It's actually a 60-degree reference angle. So now it's cosine, so I'm looking for the x value. Again, this is how we show our work for these. I have a 60-degree reference angle, which means the point I'm dealing with is 1/2 square root of 3 over 2. Now, since it's the x value, I already know the answer. It's either positive 1/2 or negative 1/2. I need to figure out which quadrant it's in. Now, since this has gone around the circle more than once, and I don't want to sit there and count it out, although that might not take that long, that is going to take you a long time, and that would be a waste of time. So here's what we do. We're going to change this to a mixed number. In other words, we're going to do long division. We're going to ask ourselves, how many times will 3 go into 17 evenly? Well, it goes in there 5 times evenly. And if I subtract, I end with a 2. So this 17 pi over 3 as a mixed number could be written as cosine of 5, number of times it goes in there evenly, and then 2, the remainder, pi over 3. And what this will do, having it as a mixed number, will help me figure out which quadrant it's in a lot faster. So, now, when I do this, remember this is 0 or 2 pi. This is pi. Now watch as I count my way around. This is a positive angle, so I'm going this way around. And I'm just going to count these. Listen to the numbers that I'm saying as I count. It's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. Do you notice that all of the odd number pi's are here and the even numbered pi's are over here? What that does is that allows me to look at just that number. As I count my way around, eventually, because it's an odd number, it's going to end up over here. So moving 5 pi will put me right there. Now I still have to move this far. Remember we said this was a 60-degree reference angle, and I need to move 2 of them. So there's one 60-degree angle, there is another, and there is where 17 pi over 3 is. So again, it's 1, 2, 3, 4, 5, and then 1 pi over 3, 2 pi over 3. Now that I see it's in the 4th quadrant, I'm moving to the right, so it's a positive 1/2, and I'm moving down, which means it's a negative square root of 3 over 2. And since I'm looking for the cosine, or the x value, it's just 1/2. Again, kind of tricky. It takes a little time to get used to it. If it helps, rewind the video and watch it again. But we'll get a couple more examples to practice with. Alright, so next one, cotangent. Don't be freaked out by the trig function. Cotangent, if you remember when we wrote down our, is it the x value, is it the y value? It's the x divided by y value. And now I need to see if this is reduced or not. So I kind of need to do some long division to see if 6 is going to go in there or not. The good news is I have to do it anyway, so might as well just go ahead and do it right away. And I'll see if 6 goes in there evenly. When I get to the remainder, it'll simplify. So how many times does 6 go into 8? Well, it goes in there 1 time. Multiply to get 6. Remember, we want to subtract to get 2, and then I usually just bring down the next, you can bring down both numbers if you want, just bring down the next number. How many times does 6 go into 22? Well, 4 times 6 is 24, so that's too big, so it goes in there 3 times. Multiply 3 times 6, you get 18. Subtract, you get a 4, bring down the 9. And now ask yourself, how many times will 6 go into 49 evenly? It should go in there 8 times evenly. And when I subtract, I get a 1. So another way of writing this, now you don't want to forget that that's a negative, that's important. You can say that this is the cotangent of negative 138 and 1 pi over 6. Now that fraction does not simplify, meaning this actually is simplified. If I would have done the long division with 34 and 6, it would have given me a remainder here that would have simplified down. Alright, so now remember, like we did over here, all I care about is this even or odd, and then move that distance. I'm going to draw a little unit circle again to show my work. This is an even number. Now notice this is negative, so I'm not going this way, I'm going that way around the circle. It's an even number, so as I count my way around, eventually I'm going to end up over here. And now I still need to move 1 pi over 6, remember, going that direction. So 1 pi over 6, which is a 30-degree reference angle, puts me right there. So I guess I wasn't showing all my work. I know it's a 30-degree reference angle. I know that means the point is the square root of 3 over 2, 1/2. And now because I'm in the 4th quadrant again, it's positive, negative. This is actually going to be positive square root of 3 over 2, negative 1/2. Now that I know what the point is, remember what you're trying to find. You're trying to find the cotangent, means take the x value, divide by the y. Remember what we said before, since the denominators are the same, when I go to multiply by the reciprocal, the 2's will just cancel out anyway. It's x divided by y. it would be negative square root of 3 over 1, which of course is implied to be there. Alright, one more of those for practice. Cosecant. Now I need to know which one that's the reciprocal of. That means I'm going to eventually take 1 divided by the y value. So I'm going to be looking for the sign. It's a negative number, important. 55 over 4, I know that 4 won't go into 55 evenly, so I know that it's a 45-degree reference angle right away. So I know I'm dealing with the square root of 2 over 2 and square root of 2 over 2. So even if I screw up and get the wrong one, I'm going to get the right number. I just have to make sure I'm in the right quadrant. Alright, so take 55, divide it by 4. See how many times it goes in there evenly. You may not have to do the long division to figure this one out. This one's a little bit easier. But go ahead and do it to get the practice. Looks like 4 will go into 5 one time evenly. And now how many times will go into 15? Should go in there 3 times evenly. And there's your remainder, 3. Remember, it's negative. So this is going to be the cosecant of negative 13 and a remainder of 3 pi over 4. So, negative 13, remember we're going that way around. It's an odd number, so eventually I'll end up here. You can count 1, 2, 3, 4, all the way eventually you get to 13. And now I still need to move 3 pi over 4, which is 45 degrees. So starting here, I'm going to move 1, 2, 3 pi over 4. So I'm actually in the first quadrant, which means that's actually the right point. It's the square root of 2 over 2, square root of 2 over 2. Now in terms of showing work, this is good. This is perfect. This is what I'd like to see. But don't just go ahead and write your answer. Now I know I'm supposed to flip the fraction over, so it's going to be 2 over the square root of 2, and then I'm going to rationalize and say it's square root of 2 over 2 times square root of 2 over 2, fancy way of saying 1. That's going to give me 2 square roots of 2 over 2. The 2's will cancel, and I know my final answer is supposed to be square root of 2. And that's good. You understand what you're doing. You've shown me everything. The one thing that I can't tell by looking at this work is I can't tell what number you're using. When I come back and I look at this, the numbers were different, but you see I kind of underlined this, telling whoever's looking at it that, hey, I'm looking at the x value. And if I didn't know that, I could figure it out when I get down here and say, oh yeah, you looked at the x value. I can't really tell which one you're looking at. And so what I would want you to do is kind of clarify that, yes, I'm looking at the sign. I want the y value. Why is that important? Well, if this was the secant of negative 55 pi over 4, it's the same answer. So it's possible that you're making a mistake but still getting the right answer, which happens from time to time on the unit circle. So you always got to make sure that you show every little detail that you can. Otherwise, again, I really don't know if you're doing that right, and when we get in class next year, I kind of make the assumption that you did it wrong just because there's a number of ways you could do it wrong and still get the right answer if you're lucky. Alright, hopefully that helps. The last kind of problem that we're going to do now is instead of them giving us the angle and asking us to find these things, they're now going to give us these numbers and ask us to figure out the angle. So, they're saying that the sine of theta is equal to negative 1/2. Now this just comes down to outright having your unit circle memorized. It's a y value and it's negative. A y value that's negative should be going down, which means it's in one of these two quadrants. And I don't know which quadrant it's in. It's actually in both. So I'm in these two quadrants. Now think about a y value being 1/2. If you have a y value being 1/2, that means the x value is the square root of 3 over 2. And hopefully you remember that that's a 30-degree reference angle, or it's pi over 6. Again, we tend to use radians for everything. I know that I should probably use radians because they give me radians over here. If they gave me degrees, then I'd probably get the answer in degrees. Alright, so now let's think about it. It's pi over 6. That's the reference angle. What would it be here? That means that's 30 degrees. This is pi, or 6 pi over 6. This would be 7 pi over 6. And that's because I'm going that way around. This would be 11 pi over 6, 30 degrees away. My picture may be not accurate in terms of the location, but it would probably be more right here, but that's not overly important. I just need to have a visual of what it looks like. Now these are positive angles. Notice that not only can I have positive angles, I can go all the way to negative 2 pi. So in other words, I found this answer, which is 7 pi over 6, and this answer, which is 11 pi over 6, but they're also saying that I could do that answer, which is negative pi over 6, because I'm only moving one of those pi over 6s. And then if I moved to here, to that one, remember this distance is pi over 6. This is pi, so just subtract them. It would be pi minus pi over 6, or negative 5 pi over 6. So you actually have 4 answers for this problem. And most of these will have probably 4 answers. So a little trick, if you can get the positive ones, good. Really good. If the negative ones are throwing you for a little bit, try to draw the picture and ask yourself, what would this distance be and what would that distance be? Alright, on to letter B. Now they start to get a little bit more tricky. Instead of giving you just a y value, I'm giving you tangent. Remember what tangent is it's y divided by x. And again, this requires me to remember stuff on the unit circle. If I take y and I divide it by x and I get 1 for an answer, there's only one way for me to get 1. I have to divide the exact same numbers. Well, think on the unit circle. Where do you have the exact same x and y values? It's at all the 45 degrees. So I know it's at 45. Now, it can't be over here because that's negative. It's here at 45, and it's down here at negative 225 because they're both negative. So I know right away that this is basically a 45-degree reference angle. And that's just because I know my unit circle really well. And as you kind of look over your unit circle, you'll get to that point. It might not actually be a bad idea. It probably sounds silly. But it might not be a bad idea to try to draw this out. List all the degrees, all the points, and all the radians all on one unit circle and time yourself. You should be able to do it in probably the first couple times you do it 4 minutes, but you should eventually be able to do that within 2 minutes. And we may actually do that in class where I time you and you have a couple minutes to do it. It sounds like it's really hard to do, but once you recognize the patterns, you'd be surprised how fast you can do that. Alright, back to our problem. Alright, so we said that it has to be both positive, the x and the y value, so when I divide I get positive 1, or both negative. I know it's a 45-degree reference angle, or we're going to use radians, so pi over 4. Well, if I'm going this way, that would be 1 pi over 4. That's one of my answers. That's the positive one. And then think about what this one would be. It's past 1, so the next one after 4 over 4 would be 5 over 4, or 5 pi over 4. There are the positive answers. Now for the negative ones, what would that distance be? Remember that this half of the circle is 1 pi, or another way of writing 1 pi would be to say 4 pi over 4. Subtract this pi over 4, and you would end up with 3 pi over 4. Now the only difference is, notice what direction you're going. You're going that way. So it's negative 3 pi over 4. And then if I look starting here, getting to this point would be pi plus that distance, which is 3 pi over 4. This would be negative 7 pi over 4. Notice that you almost went all the way around the circle. You just took that pi over 4 out. And so there are my 4 answers. Again, if you can get the positive answers for right now, great. You should be able to get the negative ones with time, but it might take you a little time. I'll try to show you something over here that might help. Alright, kind of like letter B was a little bit tricky and you had to think of the points. Same thing's going to happen with this letter C. It's asking for the cotangent, which means it's x divided by y. Now notice it's negative. That means one of these two is negative, so if you think about where you're at, it has to be in the second and fourth quadrants. I need a positive x, negative y, or negative x, positive y. Now what I want to recognize is this. We do a lot of problems where we have to rationalize like we did back here. Like we did back here. What you start to recognize is when the number inside the radical on the numerator and the number in the denominator are exactly the same, it has been rationalized already. This is actually that. Imagine if you multiply by the square root of 3 over the square root of 3, you would get this. So when I see the number inside the radical and the number in the denominator that are the same, I can kind of unrationalize it. Alright, so now you say, well, what good is that? Because this is supposed to be x and this is supposed to be y. Well, think on the unit circle. All of my values on the unit circle, if I look at my unit circle again when I'm looking at the x and y values, other than these, the ones on the x and y axis, every single one of them has what in the denominator? A 2. So what I'm going to do is I'm going to kind of manipulate this a little bit. I can do whatever I want to this, realistically. I can multiply it by 6 over 6. I can multiply by the square root of 3 over the square root of 3. As long as I do the same thing to both of these, I'm not technically changing it. So what I'm going to do is I'm going to divide both of these by 2. You say, well, what would the purpose of that be? That would mean the top, or the numerator, is 1/2, and the denominator is the square root of 3 over 2. Well, those are numbers I recognize on the unit circle. Remember, the top number we said was x, the bottom number was y. So it's 1/2 square root of 3 over 2. Now remember, we said either the x was negative or the y was negative. And so I just got to think to myself, where does that happen? Well, now that I know that the x value is 1/2, I know that this is a 60-degree reference angle, or pi over 3. So now when I come up and look at my picture, if my reference angle is pi over 3, and I have a negative 1/2 positive square root of 3, so putting me here, what would that distance be? That would be 2 pi over 3. So there would be one answer. And then if, in that pi over 3, that reference angle that I'm referring to, that is this angle here, which is this angle. Remember, that's the idea of a reference angle, goes from the ray to the x-axis. So now let's think, if this is pi over 3, all the way around is 2 pi, or 6 pi over 3, what would that distance be? And that would end up being 5 pi over 3. I know it's something pi over 3, and I just got to think about, it's in the fourth quadrant. Which one of those is in the fourth quadrant? It's 5 pi over 3. Alright, now I'm going to redraw this down here to see if I can't help you find the negatives in a different way, the negative angles. Alright, what you can do is this. You can say to yourself, I know that this distance is pi over 3, this distance here, and I know this distance here is also pi over 3. If you want, just start labeling some other information. If this distance, if we look at just the top half, if this distance is pi over 3, that means this distance must be 2 pi over 3. And same here, if this distance is pi over 3, that means this distance is 2 pi over 3. Alright, so now to actually get the negative answers, starting here, going that way, how far did you go? Just add them as you go around. It would be negative pi over 3. And then notice to get to this one, you would start here and go all the way around to there. Now add these together. It would be 1 pi over 3 plus 2 pi over 3 plus 1 pi over 3. So it's 1, 2, 3, 4 pi over 3. Remember, you're going in a negative direction. So it's negative 4 pi over 3. And there is your positive and negative answers. Alright, another thing that you could do, well, yeah, let's just leave it at that. Last one, secant. Negative 2 square roots of 3 over 3. Notice this again, just like we noticed over here. I can tell that's been rationalized. So I can say the secant of theta is equal to negative 2 times 1 over the square root of 3, or it's really just negative 2 over the square root of 3. Now remember what we usually said before, how I don't like to work with the secant, the cosecant, or the cotangent. Usually I switch it to one of the original 3 trig functions. All I have to do is remember that the original trig function, or the reciprocal of secant, is cosine. And remember, if I flip the left side of the fraction, I have to flip the right side as well. So this will equal negative square root of 3 over 2, and that's a number I recognize on the unit circle. Now when I draw my little picture, this is cosine, so remember this is like an x value. If the x value is negative, that means you move to the left. That means it's one of these two quadrants. That means you're either here or here. And now if the x value is the square root of 3 over 2, that means the y value is 1/2. That means you're looking at a 30-degree reference angle, or pi over 6. So again, if you want to do that little labeling trick, you can say, okay, that means this distance is pi over 6. That means this distance is also pi over 6. If the top half is 6 pi over 6, or pi, then this distance here would be 5 pi over 6, the distance from here to here. And same from here to here. And so now just start to add everything together. If I want the positive answers, starting here, I'm going to move a distance of 5 pi over 6. And then to get to this one, I'm going to move 5 pi over 6 plus 1 pi over 6 plus another 1 pi over 6, so 5, 6, 7 pi over 6. Or of course, if you're really good at your unit circle, you're going to know that the reference angle with a 30-degree reference angle in the third quadrant is 7 pi over 6. That'll come with time. Now to get the negative ones, moving this way, I would move negative 5 pi over 6. And then I would move negative 5, 6, 7 pi over 6. And that's how you come up with the 4 answers for that one. Again, a little tricky, a little backwards thinking, but very good problems to look at, and you'll get a lot more practice of this with this next year. Again, if you had trouble with any of the homework from any of the sections, feel free to email me. I'll try to do the best I can helping explain it to you. Otherwise, I look forward to working with you next year.